Hello students, today I am going to discuss a very common problem in mechanics, a block sliding on a inclined wedge. So here I am taking two cases. So case number one, when the mass of the block, when the mass of the block M or mass of the wedge capital M is very high compared to the mass of the block. So in this case, I can assume when block is sliding, there is a no movement in wedge. So wedge is stationary. There is a no motion, no acceleration in the wedge. Only we have to discuss the motion of block with respect to the wedge. So let us do how to approach this problem. So let us say this angle is theta. Now let us say this is my x-axis, this is my y-axis, this is already given, and now let us find this is my origin. So say this is the xy coordinates of the block. So this is my x, this is my y. Now if I want to write say a constraint equation, so I can write tan theta. Tan theta is basically this one, this is y upon this. So you can write x, or you can write say this total length is say this is L. So I can write this distance is L minus x. So tan theta equal to L minus x. From here I get y equal to L minus x tan theta. So this will give me the constant equation. So if I differentiate this equation with respect to time twice, so this will give me ay, this will give me minus ax, the component of the acceleration in the x direction, and tan theta. So this is the relation between ax and ay. So this is equation number one. So once I know ax and ay, I can find the acceleration a, which is equal to ax square plus ay square. So I have taken the direction here x and y here. Okay. So now let us see how to approach this problem. So in order to solve this problem using Newtonian mechanics, we have to consider all the forces acting on this mass. So say we'll see what are the forces are acting on this mass. Say here I have a mass m, and now the force, the gravitational weight will be acting downward. This is mg. Okay. So similarly, there will be a reaction force, okay, by the surface on the block, which will be perpendicular direction. I say this force is N. Now this angle is given theta. This angle is theta. So obviously this angle will be also theta. So this is 90 minus theta. If I draw like this, so this angle will be also theta. So this angle also theta. So now we have two forces, and now let us find the component of these two forces in the xy direction, because I want to discuss the motion of the particle. For that I am first discussing the direction, the x direction and then y direction, and then combining we are calculating the acceleration. So let us find what are the components of reaction force in the x direction and y direction. So in the y direction the component is n cos theta, and the x direction the component is n sin theta on the block. If I see the mg has a y component in the y direction, so it has no component in the x direction. So now I can write the equations. So let us say this is my uh, motion in the x direction, plus x direction. I'm writing the equation for plus x direction. So mx will be next direction. There is only one force component and sine theta. Similarly, if I write the equation in the y direction, this will give me m a y. In the plus y direction, I'm writing the equation. So y direction, the force component is n cos theta, and this is my mg. So now we have three unknowns. Okay, we have ax, ay, and then we have n, and we have three equations. Just we have to solve this three equation. This will give me the value of a. Also, if you want to find the component of mg, okay, in the inclined plane direction, the component is also equal to mg sine theta. So now let us solve this equation and find the value of acceleration. So I will take this ay. This ay is equal to n cos theta. N value, I'll put this from this equation number 1. So this will give me m ax sine theta. Then you have a cos theta, and then you have a minus mg. Cancel. Now you have the equation for ay. Ay is equal to ax cot theta minus g. So this is equation number 4, 2. So this is equation number 1. This is 2. This is 3. And now you say this is 4. And now I can write, say, I can solve this in 1 and 4. So this will give me ay value is ax cot theta minus g, and this is the minus ax tan theta. So if I solve this equation, this gives me ax cos theta plus sine theta plus sine theta upon cos theta is equal to g. And if I solve this further, this gives me ax equal to g sine theta cos theta. Now I have value of the x component. So x component is g of sine theta cos theta. And now if I put the value of here, I'll get ay is equal to minus ax, which is g sine theta cos theta into tan theta, that is sine theta divided by cos theta. This cancels out. So this gives me ay equals to minus g sine theta sine theta. Now the y component is negative because block is coming down, and our axis is, we have chosen y is in the plus direction, is up. So now if I calculate the acceleration, so acceleration will be if I solve this equation, ax square plus ay square, this will give me the value of acceleration is g sine theta. Of course, the direction will be in this direction. So here I have solved using the acceleration using x and y component. For this problem, we can directly solve the acceleration, because we can see the movement is only in one direction. So instead of taking my xy direction like this, I can simply choose that my xy direction is in, I can choose my x direction in this direction directly, and then y. Okay, and then I say this is my s, distance is s, acceleration is a. So because now movement is only x direction, block is not moving in the y direction, so acceleration in the y direction is 0. So there is only acceleration a, this acceleration a. So I can write directly equation. So I can write m d2s dt square, or m, the acceleration in the direction of s, which I called is a, ma. Now what is the force in this direction? There is only one force, mg sin theta is acting in this direction. So I can directly write this mg sin theta. So m cancel. So my acceleration is directly g sin theta. So with this simple one step, also I can solve this problem, because there is no limitation, or there is no choice of xy axis. We can choose according to our convenience. And now if I want to the x component, because I have chosen that this is my a, now this is my a, this is the x direction, this is the y direction. So automatically I can say my ax will be a cos theta, and ay will be minus a sin theta. Now a value is g sin theta. A value is g sin theta. So this is the case first when we don't have a motion in the wedge. Okay. Now let us discuss the second case where this block is also moving, wedge is also moving. Let us calculate the second problem. Now let us say this wedge is also moving in this direction. I am calling the acceleration of wedge is a omega. This angle is theta. Okay. Now let us discuss mass is m. Now let us discuss this problem also. So say I have a wedge. So I choose my xy direction here. So this is my origin. This is my x direction. This is my y direction. Okay. So let us say this is my block. This is theta. So I say this distance, this vector, or this is vector is, this is a wedge. So I say this is x wedge, and this is my x block. Okay. And this distance, because the motion in the wedge is only x direction, so I don't want y direction. And this is my, say, y block. So again, like in previous case, if I, this is the case number 2. So if I write the equation of tan theta, so tan theta gives me y component of block. Now this distance is xb minus x omega, xw, and x wedge, and this is total distance is L. I can write this is a L minus, I want this distance. So this L minus xb, x of wedge, and this gives me y of block as L minus x block x wedge tan theta. And if I differentiate this one, this will give me the equation of y component of block is equal to minus x component of block, and this is the minus acceleration of wedge. Okay, because the acceleration of wedge is only in the minus x direction. So this is the equation. Okay, so this problem can be solved in multiple ways, but I am using a inertial frame. Okay, because this frame is the rest. With respect to this frame, I am solving this equation. So the force equation will change. Okay, so let us now say write the force equation. So force equation will be for block. The force equation will be same. Okay, like what I've written in the previous slide. So the force equation for the block in the x direction, we have n sine theta. It is the equation number 1. It is the equation number 2. And similarly, my, because I am discussing the motion in the inertial frame, rest frame. So there is no other force on the block M. So my, like we have written, this was n cos theta minus mg. This is my equation number 3. And now, because now we have 4 component. We want to know ax, ay, n, and a acceleration of wedge. So we want fourth equation. The fourth equation will be given by the wedge itself. So because like here, the surface is applying a reaction force, and so according to Newton's third law, this block will also apply. This block will also apply a reaction force N on the wedge. So say this angle is theta. Okay, this is my N. If I calculate the component, so this is this angle is theta. So this angle is your 90 minus theta. So if I calculate the component of this N in this direction, so this will come out N sine theta. This is N sine theta. This is N sine theta in this direction. Okay, and this will be your N cos theta. So this is theta 90. So this is also theta. So this will be your cos theta. So the x direction, because motion in the wedge is only the x direction, so I can write the equation for now the mass is capital M. So I can write a capital M. Okay. Acceleration in the wedge. Now component is in the minus direction. I'm writing for plus x direction. So this will be minus n sine theta, because I'm discussing the rest. So I'm putting a minus here. So let us solve now these 4 equations and find out the acceleration of the wedge. So we can see from equation 2 and so this is equation number 4. So equation number 2 and 4 gives me m a wedge is equal to minus ax m. Ax of the block. These are the for block. So this is my equation, this one. And now I have to solve this one, may. So may, this is my equation number 5. May, I have the value of wedge in terms of x. Okay, so may n cos theta minus mg. So n value I can put from this equation. So this is m wedge upon sine theta, and then you have a minus, and then you have a cot theta, and then you have, say, this is minus g. Okay, so now I have m in terms of ax in terms of a wedge, ay also in terms of a wedge. Okay, so let us simplify this problem. So this gives me ax of b is equal to minus m upon m a wedge, and a y component to the block is equal to minus m upon m cot theta acceleration of wedge minus g. Okay, so let us solve now these equations and find out. So I have now ax ay in terms of a wedge. We have eliminated the n. Now say we have the constant equation, we can put the value of ay ax and we can find the value of a wedge. Okay, so ay is your minus m upon m cot theta a of wedge minus ax. So this is a minus m upon m a of wedge, this minus will be cancelled. So this will be only m upon m plus 1 a wedge. And here you have a m cot theta minus g also. So now if I solve this one, this gives me m upon m plus 1 acceleration of wedge plus m upon m cot theta. Of course, here there was a tan theta also. Here tan theta also was there. Tan theta. This is tan theta. Tan theta here. Tan theta. Cot of theta a omega is equal to g. Okay. Let us simplify this equation. So let us say this sine theta cos theta. So I can write m upon m plus 1. I'm taking writing the sine theta cos theta. So this is a sine theta cot theta upon sine theta. So this will become sine squared theta a omega plus m upon m. This will be sine squared theta a omega, and this will become g sine theta cos theta. Okay, and if I take common here, this one, so a omega will come out m upon m sine squared theta plus cos squared theta plus sine squared theta g sine theta cos theta. Now the solution is only one step away. So let us say now I want to find the acceleration of the wedge. So acceleration of wedge is equal to, say, there should be a minus sign also. So see, this is a minus sign. G, you have to go back. It should be minus sign because we are bringing this is here. So this should be minus sign. So A of block, A of this will be equal to minus G sine theta cos theta. And now this is m upon m sine square theta, and this expression sometime written also like this mg sine theta cos theta, and then you write here m plus m sine square theta. Sometimes this expression also given in the form of cos, so you can write g sine theta cos theta m upon m plus 1 is a 1 minus cos square theta cos square theta. So this is our expression. These are our expression for block. Okay, wedge, expression wedge. Now we can also calculate the acceleration of this mass. So I told you that acceleration of mass, this block, okay. So we can do it in two way, because we can calculate the x component of this block, y component of the block, the equation, and then we can find the total acceleration. Or another way, we can also find the acceleration of a block, acceleration of the block is equal to acceleration of the wedge plus acceleration of the block with respect to wedge, acceleration of block with respect to the wedge, with respect to the wedge. So we can find acceleration, assuming this is stationary, we can find the force, considering this is a non-inertial frame, we can find this one. We already know acceleration of the wedge, so we can find the acceleration of the block with respect to the rest frame. Okay, so for this, check out my next video. Next video I'll calculate the acceleration of the block with respect to the stationary or inertial frame. Thank you very much.